Atoms or isotopes and ions can be written in a couple forms. One of them is to name the element and then write the atomic mass afterwards. One of the things that confuses people is that dash there. In this case, that dash is not a negative sign, it's just a dash, and the 33 is the atomic mass. The other way to write this is that you write it with the element and then you put the atomic mass in the upper left hand corner. So the atomic mass of the second one is 109. When you first look at these, the first thing I'd like you to do is identify the element and find it on the periodic table. So in this case here, if we go and find sulfur on the periodic table, we see that it has a 16 up above. What the 16 is what's called the atomic number. The atomic number is always going to be the number of protons. So for sulfur, you always have 16 protons. Now, protons, like we identified up above, protons are positively charged. So if you have 16 positive charges, you can use that to figure out how many electrons you have. If you look, this is a neutral atom, and so there must be the same number of positive charges as negative charges. So that means that there are equal number of electrons. So 16 in this case. If there is 16 protons and 16 electrons, they end up canceling each other out. And so you end up with a neutral atom. 1, 2, 3, 4, 5, 12, 13, 14, 15, 16. So this atom, the electrons have no mass. So even though there's 16 of them, they really have no significant mass. So the mass is 33. 16 of that mass is due to the protons, but the rest is due to neutrons. So that tells us we can use that to help figure out how many neutrons there are. You have to have a number here that will add to the number of protons. So when you add those together, that is going to be equal to 33. That means that neutrons is going to be 17. We're going to use that same logic for the rest of these. Since we know that protons plus neutrons on the second one is going to equal 109, we can go to the periodic table and find silver on the periodic table. Silver has an atomic number of 47. 47 is the number of protons. And in this case, we don't see any number in the upper right hand corner. That's where the charge is usually indicated. So that means this is a neutral isotope or atom. And so there must be an equal number of electrons to make it neutral. That means 47 electrons. To get neutrons, we use the math and look at the math of 47 plus a number is going to get us 109. So we subtract 47 from 109 and you get 62 neutrons. This third problem is still silver, but something's changed. It now has a mass of 107. Well, again, when we look at the periodic table, the atomic number never changes for silver. It's always 47. So that determines the chemical identity. So 47 is the number of protons. That didn't change, but the atomic mass did change. That tells us that we have a different number of neutrons. So these two are what's called, are examples of an isotope, meaning there's a same atom, same element, but there's a different number of neutrons. There's 2 less neutrons. So there's 60 neutrons. Now, electrons, since this is neutral, it has the same number of electrons as protons, which is 47. The next two examples are both nitrogen. There's a difference on this one in that they have a number in the top right corner. That's what's called an ion. It's showing us the charge of it. So we look on the periodic table first and find N on the periodic table. N is nitrogen, and its atomic number is 7. So with an atomic number of 7, that means we have 7 protons. 7 protons, and if it was neutral, we would have 7 electrons, but it's not neutral. So we use that as a starting point. We have a -3 charge. The -3 means that we have 3 more electrons than we do protons. So we have 7 protons. In a neutral atom, we would have 7 electrons. But we don't have a neutral atom. We have -3, which means we have 3 extra negative charges. So since the negative charges are the electrons, we can conclude there's going to be 10 electrons in this ion, and we can figure out, the last thing we need to figure out is the number of neutrons. The number of neutrons is going to be what number will get us equal to 15. So 7 plus 8 will equal the mass, or 15 in this case. The next one, we have again nitrogen, so we know there's going to be 7 protons, and the atomic mass didn't change, so there's 8 neutrons again. What did change is that we no longer have a number in the upper right hand corner. There's no charge, which means it's neutral. That means that there is equal number of protons and electrons, so there's 7. Now, the question down below, it says, use the examples of the atoms above to illustrate the difference between ions and isotopes. So the ones where the ions, so an example of an ion, there is only one example out of the 4, and it's the N-3. And so that's an example of an ion because it has a charge. A charge due to an unequal number of electrons compared to protons. And isotopes, the best example of isotopes is by you need to compare the 2 silvers to each other. So in this case we have silver 109 and silver 107. Examples of isotopes are silver 107 and silver 109, which have different number of neutrons. Now you could also use the 2 nitrogens as an example, but, well, actually not for isotopes because they both have an atomic mass of 15.